Good day everyone. Today we are going to discuss about the solutions of triangles, as this focuses on finding the unknown sides and angles of the triangles using mathematical principles and formulas. In this lesson, we will learn how to solve right triangle using trigonometric ratios and Pythagorean theorem, and to solve also the oblique triangle using law of sines and law of cosines. At the end of this discussion, students should be able to first solve the right triangle using trigonometric ratios and Pythagorean theorem. Next is to solve the oblique triangle using the law of sines and law of cosines. And lastly is to apply this concept in real life situation, as these methods are useful in measuring the distances, heights, and angles that cannot be measured directly. And before solving triangles, let's define first what is triangle is. So a triangle is a polygon with 3 sides, 3 angles, and 3 vertices. It is one of the most basic and important shapes in geometry. So a triangle can be classified according to their angles into 3 types. So we have here a first acute triangle. All of the angles are less than 90 degrees. Next, the second one is the right triangle, where one angle is exactly 90 degrees. This type of triangle is commonly solved using the trigonometric ratios and the Pythagorean theorem. And lastly, the third one is the obtuse triangle, where one angle is greater than 90 degrees. In these classifications help us determine which method or formula we use in solving a triangle.
Good day, I am Jennifer G. Paparon, and now let us talk about solving a right triangle. This topic is very important in trigonometry, especially when we are looking for the missing side and missing angle of the right triangle. Now, we are going to proceed and to know what is the right triangle. A right triangle is a triangle with one right angle or 90 degrees. So the longest side is called hypotenuse, while the other 2 sides are called the legs. So to find the missing angles and missing sides, we commonly use the trigonometric ratios. A trigonometric ratios using the mnemonic SOHCAHTOA, it can help us to find the missing sides and missing angles. So means sine equals opposite over hypotenuse. Ka means cosine equals adjacent over hypotenuse. And TOA means tangent or tangent equals opposite over adjacent. Also, these trigonometric ratios can help us to find the missing sides and missing angles. Also, we can use the Pythagorean theorem. So, this is the properties of a right triangles. So we have c squared is equals to a squared plus b squared to find the missing sides. And to find the missing angles, we can use a plus b equals 90. And now, let us proceed to the examples of solving a right triangle.
Example number 1. Solve the right angle with side C equals to 15 units and theta equals to 38 degree. So first step, we draw the figure and label its part. And then, we solve for A. A is equals to 90 degree minus 38 degree is equals to 52 degree. A and theta are complementary. Now, we will solve for B, and we will use the sine ratio. Sine theta is equal to B over C. Next is we substitute the value to the formula. Sine 38 degree equals to b over 15. And then we multiply both sides by 15. And then we calculate. B equals to 9.23 units. Next is we solve for side A. And we will use the cosine ratio. Cosine theta is equals to A over C. Next is we substitute the value to the formula. And then we multiply both sides by 15. And then we calculate. So A equals to 11.82 units.
In this figure, we are given that side A is equal to 12 meters, angle theta is equal to 27 degrees. Our goal is to find the missing sides and angles of the triangle. So first, we draw and label the triangle properly. Now let's solve as for side C. We use the cosine ratio because cosine relates the adjacent side and the hypotenuse. So cosine theta is equal to A over C. Substitute the given values. Cosine 27 degrees is equal to 12 over C. Next, we solve for C by cross multiplying. So C is equal to 12 over cosine 27 degrees. Using the calculator, we get C is equal to 13.47 meters. Next, let us solve for side B. We use the tangent ratio because tangent relates the opposite side and adjacent side. Tan theta is equal to B over A. Substitute the values. Tan 27 degrees is equal to B over 12. Multiply both sides by 12, so it will be B equals to 12 tan 27 degrees. Then we calculate. So B is equal to 6.11 meters. And finally, let's solve for angle A. Since the triangle is a right triangle, the two acute angles are complementary, meaning their sum is 90 degrees. So angle A is equal to 90 minus 27 degrees. Therefore, angle A is equal to 63 degrees.
Example number 3. Solve the right triangle with side B is equal to 9 feet and alpha is equal to 41 degrees. First, draw a figure and label the parts. First step is to solve for our theta. Since our alpha and our theta are complementary, this means that theta is equal to 90 degrees minus 41 degrees, which means our theta is equal to 49 degrees. Now let us solve for our A. We use tangent ratio. Then we substitute. Then multiply both sides by 9. Then calculate. Therefore, our A is equal to 7.88 feet. Next is to solve for our C. Here we use our cosine ratio. Next is substitute. Then cross multiply. After that, we calculate. Therefore, our side C is equal to 10.31 feet.
For example number 4, solve the right triangle with A is equals to 7.5 meters and C is equals to 12.5 meters. To solve the right triangle, given A is equals to 7.5 meters and C is equals to 12.5 meters. The first thing that you have to do is to draw the figure, which is the right triangle, and then label the parts. So this is now the right triangle. And then to solve for B, you have to use the Pythagorean theorem. So this is the formula of the Pythagorean theorem. And then you have to substitute their value, where A is equals to 7.5 and C is equals to 12.5. So the equation now is 7.5 squared plus B squared is equals to 12.5 squared. Then after that is to compute the squares. So it is now B squared is equals to 156.25 minus 56.25. And then you have to subtract it and it will result to 100. After that, you have to take the square root, which results to 10 meters. So to solve for the theta, first is use the sine ratio. So it is sine theta is equals to A over C. Then you have to substitute their value, which is sine theta is equals to 7.5 over 12.5. And then take the inverse of sine. So theta is equals to sine inverse, which is this is the inverse of sine 0.6. Then theta is equals to 36.87 degree. To solve for the angle alpha, you have to use the complementary angles. So alpha is equals to 90 degrees minus 36.87 degrees is equals to 53.13 degrees. So that is now the value of the angle alpha.
First, we identify the given values. The side B is equal to 14 yards and the angle is 63 degrees. Since this is a right triangle, we know that the two acute angles are complementary. To find angle A, we subtract 63 degrees from 90 degrees. Therefore, angle A is equal to 27 degrees. Next, we solve for side A. We use the tangent ratio because tangent relates the opposite side and the adjacent side. The formula is tangent of theta equals opposite over adjacent. Substituting the values, multiplying both sides by 14 gives us A equals 14 tangent of 63 degrees, and using the calculator, you get A equals 28.15 yards. Now, we solve for side C, which is the hypotenuse. We use the cosine ratio because cosine relates the adjacent side and the hypotenuse. The formula is cosine of theta equals adjacent over hypotenuse. Substituting the values, cross-multiplying and solving for C. Using the calculator, the value of C is approximately 30.89 yards. Therefore, the complete solution is angle A equals 27 degrees, side A is 28.15 yards, and side C equals 30.89 yards.
Solving oblique triangles and the law of sines. Solving an oblique triangles means finding the way of its sides and the measurements of its angles. The law of sines can be used to solve a triangle in which one side and two angles are known. The three known measurements can be abbreviated using SAA, or a side and two angles, or ASA, two angles and the side between them. The law of sine states that if uppercase A, B, and C are the measures of the angles of a triangle, then lowercase a, b, and c are the lengths of the sides opposite these angles. Then, side A is over sine A is equal to side B over sine B is equal to side C over side C. The ratio of the length of the side of any triangle to the sine of the angle opposite that side is the same for all three sides of the triangle. The ambiguous case, or the SSA, consider a triangle in which side A, side B, and angle A are given. This information may result in one triangle, one right triangle, no triangle, or two triangles.
Next is the area of oblique triangle and the law of sines. These topics are important in trigonometry because they help us solve triangles that do not contain a right angle. Such triangles are called the oblique triangles. So let us first discuss the area of an oblique triangle. We already know that the basic formula for the area of a triangle is area equals 1/2 times base times height, where B represents the base and H represents the height. However, in an oblique triangle, the height is not always directly given. Because of this, trigonometric functions are used to express the height in terms of a side and an angle. Using the sine function of sine A equals h over b, solving for h is equals to b times a. Substitute this value into an area formula. So area equals 1/2 times c times h. After substitution, we get the area equals 1/2 times c times b times sine a, which simplifies to area equals 1/2 times b times c times sine a. So the lesson also represents the equivalent forms of the formula. Area equals 1/2 times b times c times sine a. Area equals 1/2 times a times b times sine c. Area equals 1/2 times a times c times sine b. These formulas are used to depending on the given sides and included angle. Now let's move to the law of sines. The law of sines is used when two angles and one sides are given, or two sides and a non-included angle are given. The formula for the law of sine is A over sine A equals to B over sine B equals to C over sine C. In this example, the given values are B equals to 62 degree, C is 73 degree, and the small b is 15 centimeter. The first step is to find angle A. Since the sum of the interior angles of a triangle is always 180 degree, so we use A plus B plus C equals to 180 degrees. Substitute the known values. So A plus 62 degrees plus 73 degrees equals 180 degrees. Solving A equals to 45 degrees. So after finding the angle A, we apply the law of sines to find side A. A over sine 45 degrees equals to 15 over sine 62 degrees. And solving for A equals to 15 times sine 45 degrees divided by sine 62 degrees. Using the trigonometric values, the value of A becomes approximately 12 centimeters. Next, let's solve for the side C. So C over sine 73 degrees equals 15 over sine 62 degrees. So C equals to 15 times sine 73 degrees divided by sine 62 degrees. So the answer is approximately 16.2 centimeters.
Example number 2. Solving an ASA triangle using the law of sine. Solve the triangle ABC if angle A is equals to 50 degree and angle B equals to 70 degree and side C equals to 12 centimeter. Round the measures to the nearest stand. First, we begin by finding the C. We all know that the sum of the measures of a triangle's interior angle is 180. Then we will use A plus B plus C equals to 180 degree. And then we substitute the given value and add and simplify. And after that, we subtract 120 degree from both sides. Therefore, angle C is equal to 60 degree. Next, we will use the law of sine. To find A, we will apply the formula side A over sine A equals to side C over sine C. And then, we will substitute the given value. Next, we will do cross multiply and divide both sides by sine 60 degree. After that, we simplify and solve for side A. Therefore, side A is approximately equal to 10.61 centimeter. Next, we will find the side B. First, we will apply the formula of law of sines. Side B over sine B equals side C over sine C. Next, we will substitute the given value. And then, we perform cross multiply. After that, we divide both sides by sine 60 degree. Next, we will simplify and solve for side B. Therefore, side B is approximately equal to 13.02 centimeter.
Example number 3. Solve triangle ABC if A is equal to 30 degrees and side A is equal to 7 and side B is equal to 10. Round lengths of sides to the nearest tenth and angle measures to the nearest degree. The known ratio is side A over sine A, or 7 over sine 30. Because side B is given, we use the law of sines to find angle B. So, side A over sine A is equal to side B over sine B. This is the law of sines. So, we substitute the angle 30 and the side A and side B. And then cross multiply to isolate the side B. And then divide both sides by 7. And then you simplify it. After that, we take the inverse of sine. Therefore, our angle B is equal to 45.58 degrees. Now, to solve for C, we use 180 degrees minus B1 minus A, or 180 degrees minus 45.58 degrees minus 30. This results to C being 104.42 degrees. Side C that lies opposite this 104.42 angle can now be found using the law of sines. So, side C over sine C is equal to side A over sine A. We apply the law of sines. Then we substitute our values. After that, we cross multiply. And then, we divide both sides by sine 30. Next is to multiply and solve for side C. Therefore, our side C is equal to 13.56 units.
Now, let's proceed to example number 4, which is solving an SSA triangle using the law of sines. For example number 4, we have to solve the triangle ABC. Given angle A is equals to 60 degrees and the side A is equals to 5 centimeters and the side B is equals to 8 centimeters. The known ratio is A over sine A or 5 over sine 30. Because side B is given, we use the law of sines to find angle B. And then we have to substitute the given values. So this is the equation now. After that, we have to cross multiply. So the equation now is 5 sine B is equals to 8 sine 60. Then we have to divide it by 5 both sides. So 5 sine B over 5 or divided by 5 or and then 8 sine 60 over 5 or divided by 5. So sine B is equals to 8 times 0.8660 over 5. So we have to multiply and then solve for the sine B. So the result now is that sine B is approximately 1.39. Sine can never exceed 1. There is no angle B for which sine B approximate 1.39. So there is no triangle with the given measurements.
In this problem, we are asked to find the area of an oblique triangle with side C equals 40 meters and B equals 20 meters. And an included angle of A equals 102 degrees. To solve this, we use the formula for the area of an oblique triangle, which is 1/2 times side C times side B times sine of angle A. Substituting the given values, multiplying 1/2 by 40 and 20 gives us 400. Using the calculator, sine of 102 degrees is approximately 0.2781. Multiplying 400 by 0.9781 gives us 391.24. Therefore, the area of the triangle is approximately 391 square meters.
Now, let's move on to the law of cosines. The law of cosines is used to solve triangles in which two sides and the included angle are known. That is the side angle side case, or when all three sides are known, which is the side case. Mathematically, it expressed with these formulas. This means that the square of one side equals the sum of the squares of the other two sides minus twice their product times the cosine of the included angle. When solving an SAS triangle or the side angle side triangle, we must follow these 3 steps. The first step is use the law of cosines to find the side opposite the given angle. The second step is apply the law of sines to find the angle opposite the shorter of the two given sides. This angle is usually acute. Then finally, find the third angle by subtracting the measures of the given angle and the angle found in step 2 from 180 degree. Next is we have the Heron's formula, which allows us to find the area of a triangle when all three sides are known. The formula of this is area equals the square root of s times s minus a times s minus b times s minus c, where s is the half the perimeter or 1/2 of a plus b plus c. This formula is especially useful when no height is given. Lastly, when solving an SSS triangle or side-side-side triangle, you must follow these steps. First is, we start by using the law of cosines to find the angle opposite the longest side. Then, we use the law of sines to find either of the two remaining acute angles. And then, finally, find the third angle by subtracting the measures of the angles found in step 1 and step 2 from 180 degree. Now, let's have an examples.
Example number 1. Solving an SAS triangle. Solve the triangle with angle A equals to 30 degree and side B equals to 15 and side C equals to 30. Round the lengths of sides to the nearest tenth and angle measures to the nearest degree. First, since we are given two sides and an included angle, therefore we will apply the 3 steps procedure for solving an SAS triangle. Step 1. We will use the law of cosine to find the side of opposite to the given angle, and we will apply the law of cosine to find A. Next, we will substitute the given value to the formula, and we perform the indicated operations. And then, after that, we will take the square root of both sides and solve for A. So therefore, side A is approximately equal to 18.59. Step 2. We will use the law of sines to find the angle opposite the shorter of the two given sides. So this angle is always acute. First is we will use the law of cosine. Side A over sine A equals to side B over sine B. Next, we will substitute the given values. And then, we cross multiply. And then, after we multiply it, we divide both sides by 18.59. And after that, we simplify. We take sine B equals 15 sine 30 degree over 18.59 and simplify it. After that, we will solve for angle B. So we will take the inverse of sine and solve for angle B. So therefore, angle B is approximately equal to 23.79. Step 3. Find the third angle. We will subtract the measures of the given angle and the angle found in step 2 from 180. So C is equals to 180 degree minus A minus B. Then we will substitute the given value, and ABC is approximately equal to 79 degrees.
In this problem, we are given the three sides of triangle ABC. Side A is 10, side B is 12, side C is 16. Our goal is to find the measures of the three angles. Since all three sides are given, this is called an SSS triangle, which means side, side, side. To solve it, we use the law of cosines. First, we identify the longest side. The longest side is 16, the side C. We begin by finding the angle opposite it, which is angle C. We use the law of cosines formula. C squared equals to A squared plus B squared minus 2AB cosine C. Now, substitute the given values. So it will be 10 squared plus 16 squared minus 12 squared over 2 times 10 times 16, and it will be 212 over 320. Then we simplify, it will be cosine B equals to 0.6625. Then we're gonna use the inverse cosine. So the cosine B will be 48. Next, we will find the angle A. It's just the same, apply the law cosine to find A. So cosine A is equal to B squared plus C squared minus A squared over 2AC. So substitute the value, it will be cosine A equals to 12 squared plus 16 squared minus 10 squared over 2 times 12 times 16. So therefore it will be 144 plus 256 minus 100 over 384, and it will be 300 over 384. Then simplify, it will be cosine A approximately of 0.78125. Then we're gonna use the inverse cosine function. Then it will be cosine A is equal to 38. Then we're gonna find the third angle. We're just gonna subtract the measures of the angle found in step 1 and step 2 to 180. So C is equal to 180 degree minus B minus A. Substitute the values. It will be 180 minus 48 minus 38, and it will be 94 degree.
Example number 3. Use the law of cosine to find the measures of the three angles of the triangle ABC if the side A is equal to 3 and side B is equal to 4 and side C is equal to 6. So step 1, we will find the angle A. We apply the law of cosines to find A. Then, we substitute our values. After that, we simplify and solve for cosine A. Therefore, our angle A is equal to 26 degrees. we will find our angle B. We apply the law of cosines to find angle B. Then, we substitute the values. And simplify. Therefore, our angle B is equal to 48 degrees. Next is the third angle, or the angle C. C is equal to 180 degrees minus A minus B. (180 degrees minus 26 degrees minus 37 degrees is equal to 117 degrees.
For example number 4, find the area of each triangle by using the Heron's formula. For example number 4, using the Heron's formula, find the area of each triangle round to the nearest square unit. Given A is equals to 16 meters, B is equals to 10 meters, and C is equals to 8 meters. So the first thing that we have to do is to calculate the semi-perimeter. So we have to apply the semi-perimeter formula. So this is now the formula of the semi-perimeter. So we have to substitute it with the given value. So the equation now is S is equals to 1/2 times 16 plus 10 plus 8. So you have to add them and then multiply. So which results to 34. Then we have to divide it by 2. Then the result now is 17. So this is now the value of the semi-perimeter. So to calculate the area, we have to apply the Heron's formula, which is area is equals to square root of S times S minus A times S minus B times S minus C. So we have to substitute it with the given value and then simplify it and solve for A. So the equation now is area is equals to square root of 1071. So the square root of 1071 is approximately 32.72 degrees. So we have to round it to the nearest square unit, which results to 33 meters squared. So the area of the triangle is 33 square meters.
In this problem, we are asked to determine the distance between two aircraft. The given values are angle A equals 42 degrees, side B 35 miles, and side C 20 miles. Since we are given two sides and the included angle, we use the law of cosines. Substituting the given values, next, we simplify the equation. So the equation becomes a squared equals 1225 plus 400 minus 1400 cosine of 42 degrees. Using the calculator, cosine of 42 degrees is approximately 0.7431. Multiplying 1400 by 0.7431 gives us 1040.34. Now subtracting, we get 584.66. To find the value of A, we take the square root of both sides. The square root of 584.66 is approximately 24.2. Therefore, the distance between two aircraft is approximately 24.2 miles.
To summarize, the lessons explains how trigonometric formulas are used in solving oblique triangles. The area formula helps determine the area using two sides and the included angle, while the law of sines helps solve missing sides and angles accurately.